Welcome to the Anti-Pattern Podcast, your ticket to the revolution in digital thread technologies. Please welcome, live from Mannheim, Germany, your hosts, Christian Muccio and Michael Fenning.
Hello and welcome everybody again to the Anti-Pattern Podcast. Together with me, as usual, is Christian here in the middle of Mannheim. My name is Michael, and today is already our 21st episode. And this is the episode you guys have been waiting for, because this is the second, more detailed episode about industrial AI. And so to get us started, I just wanted to add a comment from the CEO of IBM that just came out a couple of days ago. And he basically stated that what we currently experience in AI is a big bubble, right? Who gets that? There is a big bubble, and that's not a big deal, because if you look back into .com, right, 2001, the bubble just basically brought back the valuations of the companies to a more recent level, right? That was actually the case, but the technology survived, right? So don't make the mistake to think that AI is going away just because the bubble is bursting, right? It's not going to happen. It just brings back the valuation of companies, right? And he stated that currently so much investment is ongoing in AI, and he doesn't see the economics for it, right? Because there's this much money flowing directly into investing in GPUs, in data centers, in all of that kind of stuff. And then on the other hand, the business value that is actually created by AI, right? The numbers that are mentioned there, they stay in there's no big relation between the two, right? And there's not enough knowledge yet about how actually beneficial it could be to really use AI in a big context, right? So there is a lot of question marks around it, right? Does it really make sense to invest trillions of dollars into data centers and GPUs and all that? And then on the other hand, the business value is maybe billions, right? No one knows really yet. So this is still an open field and a big question mark. And but we did something. We did not discuss the whole picture. We had our AI research day 2 weeks ago with a couple of friends of us. And Christian, did you like it?
Absolutely. So it was a really cool event. We had 16 people from 12 organizations in the, not in the Muffinex, but in the Cubex, another startup center here in Mannheim. And I think everybody learned a lot, because we took all the different viewpoints the organization brought in on the topic of industrial AI. And so we ended up discussing what is so special about industrial AI. What is the difference to AI usage in a personal way or in other means? And also the question arose up, how good do we need, or does a reasoning need to be in future?
Right.
As well as, isn't there some kind of reference architecture we can use?
Right. And on the reasoning part, there was this Apple paper, I guess already a year ago nearly, right? That was actually raising the question, is it really reasoning that the LLMs are doing, or is it just a really, really good autocomplete, right? And that was something that we discussed a lot, actually. And then the reference architecture, as you said, right? Something that we want to discuss today. And for today, we structured the episode in those three big brackets, right? First of all, what's so special about it? What's the reasoning going to be, or how much do we need it, right? And then last but not least, the architecture question, or the reference architecture question. Right. And so from that perspective, we did a first implementation of something called MCP. What's that about?
Yeah, so MCP came up beginning of this year, I guess, released by Anthropic, and it's the Model Context Protocol, which is it's a pretty nice concept. It's not much. It was even easy to implement for our platform,
right?
Which is I would call it a communication protocol between tools and LLMs, or a recipe how an LLM can use and access a tool.
And what we did basically from a use case perspective is we we have ontologies in our application in the core, right? So we can define ontologies or bring them in from the outside, right? How they are defined, and together with the MCP, we're able to just basically ask an AI agent, give us the data model of something that was defined in there, and you find the definitions in that schema.org definition. Give us what was it? A JSON?
An address.
In an RDF.
In an RDF format, right? In an
Right.
RDF XML serialization. And that worked out really, really good. And
Yeah.
it
Magically, basically.
And it showed very good what it means if LLMs find something which is machine readable. It's still better than any other information it has to interpret, but we will come to that later. Because in the end, we need also to talk about this big elephant in the room nobody wants to talk about.
Right. A friend of us, he's working for one of the AI companies. He said there's this big elephant in the room that nobody wants to talk about, and it has to do with semantics. But let's save that for the end, right? Let's first come to those three questions that we wanted to use to structure the podcast in. First of all, so what's so special about industrial AI, in your view?
Yeah. So I think the most obvious point is that we need a grade of accuracy that we don't see today, which means the LLM or SLM needs to have knowledge, exact knowledge about your product, but also general knowledge, which makes it pretty expensive to train those models. And the question is, will a small or medium-sized company ever train its own model?
Doesn't look like it in the moment. Yes. Yeah.
And together with accuracy, and we also need to get rid of the hallucinations.
Yeah, no room for hallucinations. Yeah,
this is something we cannot afford in industrial AI. So you cannot do requirements engineering or build up your MBOM wrong because your LLM hallucinated and then you cannot produce it. This is something we definitely need to get rid of.
Right.
And therefore, probably better reasoning.
Which would be the second question, right? So probably better reasoning. And we discussed a lot how could we do that, right? How could we enhance reasoning? Of course, you could choose the LLMs, the standard models from out there that are better at reasoning, right? There's this comparisons usually done in in weekly weekly intervals, right? So where you see what is the best one in reasoning, right? That's the one thing. The other thing is that we thought about. Does it make sense to bring in additional models that are already existent? We don't call them AI models, right? This is just math models. This is simulation models, right? And add constraints to the architecture, right? To that the AI is constrained by those models, which means you can find a solution for us, but the solution must be within the constraints given to you from the simulation model. Right? So that would help a lot, right? Because then all of the nonsense answers are out of the picture, right? So you can shrink the solution space basically, right? That makes a whole lot of sense to us. The question is just how exactly are we going to do this, right? Right. And then reasoning. The other thing in terms of reasoning, of course, is there's this world concept. Someone proposed a new Turing test, right? Because the Turing test was basically passed by the LLMs already, right? Many people actually really don't understand the difference between talking to an AI or talking to a human being anymore, right? So the Turing test is kind of already solved or done, right? Is there something better than this? And I guess they refer to the world test, something like this, right? And one thought experiment that I have been, encountering is, would an AI actually understand a breakthrough innovation? Like, you're Newton, I'm Einstein. We can switch it if you want to. You're Newton, I'm Einstein, and all the model out there, they have been trained on Newton's physics, right? And classical physics, by the way. And then Einstein comes around, right? And what he predicts is contradicting everything the AI has learned, right? And will it understand from a reasoning perspective that let's say the theory of relativity, right, is actually correct because we have evidence, we have empirical data that actually shows it's working out, right? Can you show us the reasoning? How did you get there, right? Or would it just say, plain and stupidly, sorry, Einstein's wrong because the last 15,000 papers I've read did something different, right? So, and that's an open question. right?
Yeah.
That's not yet answered.
Yeah, there was this other. It is also some months ago that an LLM solved one mathematical question.
Right. Yeah.
And this was also the reason to discuss, is it really reasoning? How could it prove this mathematical problem without reasoning? Is it really possible?
Was it just coincidence? Yeah, no. Yeah, so that's questions that are really, really relevant for industrial AI as well, right? Because the severity is bigger, right? If you do something wrong, it's usually costly or even dangerous, right? Car could, drive autonomously against the next wall, right? It's not a good thing. So that's that part. And then the last question, maybe in that context, then is, so imagine. So two components are already there, right? We said we want to talk about reference architecture. So one component is an LLM, right? Or multiple AI agents, whatever, right? It's the one thing. The other thing is those physics models that we just talked about, right? So two components that need to be combined in order to make industrial AI work. What other components do you see necessary for a reference architecture?
So basically, of course, also your knowledge has to come in.
Yeah.
So and this has to happen very quick. So that means you need a high performance knowledge graph, which, by the way, we are building.
This is what we're building. Yeah.
And MCP, not sure if it will. So this acronym will survive the next years, but something in between, something like that, and is also a component for this. And in the end, we need to talk about semantics again.
Right. And that already points to the big elephant. Let's come to that in a second. Just to summarize, so in terms of components in the reference architecture, we say MCP, maybe it will be renamed or we'll need to find something else, but MCP is there. Then we have the knowledge graph, depending on if it's just one or multiple knowledge graphs, right? Where do you store your proprietary information? Does every organization have their own knowledge graph, right? And if they want to exchange data to the next organization, they have their own, and then they need to exchange data. How will that be working in the cloud anyway, right? So this is that question. And then we have the math models or any other existing models or proprietary data that comes in from the outside. And then what else did I miss? And then of course that information needs to flow freely between all of that, right? So it doesn't make sense if you have those components and they cannot talk to each other. So openness plays a big role in the realization of industrial AI. If things are not openly flowing, if information is not flowing from one to the next, right? How do you want to really make sense of your data, right? So that's for sure. And then now the elephant. The big elephant in the room is basically speaking when you introduce AI to the industry and you face a situation, and that's usual, right? That happens all the time. You come to a company and you see, they have 700 different instances of many different already commercial tools already, right? And on-prem, most of them on-prem. They migrated to the cloud a little, of course. In our area, not as much as an ERP, but yes. And so they migrated that stuff in the cloud, but still, it's data sitting in tables without a lot of semantics. And the idea that many people have saying that there will be AI agents logging in with my credentials, with the user's credentials into a gazillion of different tools, where else the data is described differently, where no semantics are added basically, or very weak semantics. How should that actually work out? Right. So how good is the quality of what the AI is doing if the AI does not understand dependencies? Right. This is the same thing as over here. Right. And what does that mean? Right. Where's the meaning coming from? Right. So our strong belief, if you really want to introduce industrial AI, is that we need to introduce
a digital thread.
A digital thread based on a knowledge graph. Right. However you want to do it, right? The knowledge graph itself, there are multiple strategies how to do this or how to set it up. Right. So this is crucial. And without that,
sitting on top of the source information,
right.
And with this knowledge graph, you have the possibility to add semantics via the integrations. Even if your tool, your original tool, is not able to do that or was not built to do that,
right?
You can do that while integrating data.
Right. And talking about integrating data. also interesting and related to that question is, of course, the IP protection part. Right? And this is another misunderstanding, in my view at least. Please correct me, guys. Write in the comments if I'm completely off here. But the basic understanding many people have is a little naive also in that regard, that they say, I want to compare, or I'm comparing AI with a human brain, right? And just because I tell something to an AI doesn't mean it will memorize it, right? It's not always the case, right? It depends a little on the architecture, because can it actually persist information, or is it just giving you an answer based on the input, right? And then forgets everything about it because it cannot persist anything, right? So that's the comparison is not, you don't have to be so afraid to talk to the AI if the architecture is done correctly, right? It doesn't necessarily remember what you were mentioning, right? And that, from a reference architecture perspective, that could mean that you have an LLM, an SLM sitting there, and you have your proprietary information in the knowledge graph, right? And you describe it here, you give it to the LLM via the context, right? The context window, you say this part of it is necessary for that question, give it to the AI, and the response will also come back to the knowledge graph and will be saved there. So in other words, you save your proprietary knowledge in the knowledge graph, and everything that goes to the AI, there is no way that it can memorize it because there is no persistence. It's just the service of an AI agent somewhere, right? Last word about this. Not so sure about ChatGPT here, because ChatGPT comes with their own persistence, of course, right? But that's something you don't see. That's behind the curtain, right? So for industrial AI, you need to open up the curtain and say, okay, where's the AI and where is actually persistence happening, right? And then to make it really secure, the only thing you really need to secure then is the connection, right? Is the exchange of data, right? And that needs to be protected anyway, right? With or without AI, right? So that's also part of the truth about industrial AI in its introduction. And maybe last but not least, how far do you think are we away from an actual usage of industrial AI on a large scale? How many years? What do you think?
Very good question. Very good question. On the one hand, I see the emerging possibilities. We already said it in the last podcast about AI. Even when we are using AI for coding, the possibilities within this year were growing from month to month. Astonishing, really astonishing.
Right.
So this is the hopeful part.
Right.
And the other part is, where are we on the hype cycle? So what is real? Are we already on top of the edge, and there will not come so much more?
Right.
Really hard to say.
Let's see. So
adoption rate is a different story.
Yeah, agree. So from our perspective as a company, my feeling is we are not part of the AI hype per se, right? We are attached to it a little bit, right? We are not an AI company per se. We don't build our own LLM. We don't do that, right? We use LLMs and we build a knowledge graph and we bring together the different pieces that you need, right? That's what we do. And I hope, my best guess for in that scenario is that we're lucky enough that we will survive the hype, and even if the bubble is bursting, right? Because we do stuff that is valid or that is beneficial, valuable for people with or without AI. It makes sense in an AI setting. It makes sense without AI, right? And this is what I'm counting on. And I would call this, you always talk about catching the wave, right? You need to catch the wave, this AI wave now, right? I think we are a little behind the wave itself, but if it bursts, we kind of tunnel through it, right? And we just stay,
that's a nice picture.
Stay under the radar, work on what we have to do anyway, right? And evolve and grow the company slowly but steadily, right? And not, be part of the whole volatility curve, right? Because today you get 5 million in investments, and tomorrow AI is out because it has proven to be not as successful as intended, right? And then all your financing is going away, right? So we don't want that. So we stay a little conservative here and develop the company slowly.
Yes.
Right. So yes, thank you.
Nothing to add.
So we reached agreement on that part. Very good. And then, last but not least, so thank you very much for listening in. This was the second podcast about AI. Next podcast will be the last one this year. This will be the special Christmas episode with another special topic. And till then, talk to you. Then see you soon. Have a nice, what is Advent in English?
That's a good question. I think it's really Advent. So when we did the Advent calendar in the MBSE podcast years ago, we also looked up this word. And the interesting thing is that the concept of an Advent calendar, where you open a door or a window,
chocolate usually in it,
usually for chocolate or other sweets, each day in December. I think it's not really known outside Germany.
Okay, it's not really known outside Germany. So okay, good. Then I'm not sure if it's accurate or if it's. I hope I do not offend everybody if I say we wish you a very nice Advent time till Christmas. So the weeks till Christmas. And with that being said, thank you very much for listening in, and talk to you and see you next time. Bye-bye.
Goodbye.